Hello everybody, welcome back to my channel. I'm Amir Salam, and in this particular video I'll be teaching you the topic of linked list of data structure algorithms. Now, I know a lot of you guys are already scared when you hear this word, data structure algorithms or DSA. Don't worry, I'm on a mission in this particular video to explain linked list topic of DSA in as easy manner as possible. Okay, so make sure you stick on until the very end of this video so that you'll get a proper understanding of what are linked list. Yeah, so as I said, I'll be teaching only the topic of linked list. I'll be covering concept like what is data structure algorithms, type of DSA, and linked list. What all do we need in order to build a linked list, and all of these topics I'll be explaining it to you with a code example. So make sure you'll grab a pen, notebook, and your laptop in order to code all of things which I'll be teaching to you parallelly. So without wasting any more time, let's jump right into the video. So, what is a data structure algorithms? In simple words, data structure algorithms are the rules which you've got to follow in order to store the data on your computer system efficiently. Now, why do you have to store data on your computer efficiently? Well, this helps you in order to fetch this data for future, operations and operations on the data. What are these operations? And that can be insertion, deletion, searching for some particular data in your data set. Well, all these operations can run efficiently if your data is properly managed and organized. So data structure algorithms, as I said, it's a way of organizing data on your computer system. It focuses primarily on organizing it efficiently. Then what are different type of data structure algorithms? The different type of DSA are stack, linked list, queue, arrays, graph, etc. Well, that was a basic introduction to data structure algorithms. Now let us dive deep into linked list. What are linked list? The name itself suggests, refers to it, right? Linked list. So linked list is a sequential data structure. In sequential data structure, we mean the data is organized sequentially, that is, one after another. You can visualize linked list in this manner. Consider a train to be a linked list. The engine compartment is the start of linked list, and the other compartments or coach are the nodes. Okay, what is a node? Node is a part of linked list which stores data. Okay, so as I said, a node is placed one after the another sequentially, just like a train. And these nodes contain two type of data primarily. One is the data which you want to store in them, and second is a pointer. Now, why do we need a pointer in linked list? Well, let me tell you, a pointer, each node must contain a pointer which refers to the next consecutive node. So, as I said, with the help of pointers, each and every node in linked list is interconnected, okay, connected to each other sequentially. Hence, we'll be building a linked list. Okay, so I guess I'm done with this. Now, what is one basic difference between array and linked list? Both are similar, right? Both are storing data sequentially, both array as well as linked list. But the primary difference between linked list and array is memory allocation. In arrays, the memory is allocated before executing, okay, during the process of execution, and it cannot be changed. That is, array has static memory allocation. Once the memory has been allocated by the compiler, you cannot change it during the runtime. Whereas with linked list, it comes with dynamic memory allocation, all thanks to the function known as malloc, that is memory allocation. With this function, you can allocate memory dynamically. That is, when the program is being executed, you can increase the memory space which have been allocated to particular block of code. Okay, so with this you can increase as well as shrink the memory allocated dynamically. So this is one major advantage using linked list over arrays. Okay, so I hope I have explained to you the concept of linked list, data structure, and difference between arrays and linked list in a quite short amount of time. Okay, so if you're done, let's move on to the next part. Now, what what all do we need in order to build a linked list? Well, basically you need understanding of four particular concept. The first one is a pointer. Now let us understand what are pointers. Pointers are yet another variable in C. Okay, they're just another variable in C, but with a small twist. Pointers store the address of another variable as their value. So I hope I'm clear. Pointers store the address of another variable as their value. To explain this to you in a much simple manner, consider I'm person X, okay? I have my friend person Y. Person Y has address to me, okay? Where do I stay? For example, if I stay at house number 1 in city 2, and this address is stored with my friend person Y. If any third party or third person has to approach me but is not aware of my address, he can go to my friend, right? He can ask my friend where do I live. He can get my address and through him he can contact me, right? So my friend is acting like a pointer who is having my address as his value. So I hope I'm making things clear over here. I hope the term pointers and the concept of pointers is now clear for you guys. Now we are done with the theory part of the pointers. Now let us understand pointers with a small code. Let us write a small code for to understand pointers. Okay. Okay, so I've entered into the main function and here I'll declare two variables. One to store the data and another one will be a pointer. So integer A, which will have value 5, and yes, pointers will also have a data type. So the pointer which I'll be creating here will be of data type integer. Integer, you have to declare pointer using the symbol asterisk. Okay, pointer. Done. Now what I'll do is I'll try to print the value which is stored in A directly. Okay. So what will be the output? Obviously, we'll be getting 5 as the output. See, the value of A is 5. Here we are accessing the value of A directly. Now let us tweak this program. We'll use pointer in order to access the value of A. What I'll do is pointer is equals to, now I'll pass the address of A to pointer. Okay, I've passed address of A to pointer. Let us print the value of A now. Backslash n. Now with the help of pointer, see, as you can see, I'm using pointer in order to access the value of variable A. See, I'm getting the value 5 itself. This is how simple it is working with pointers. I hope you're clear with pointers. Now let us jump to the next topic, that is structures. Now what are structures in C? To simplify structures, consider them in such a way that structures are collection of multiple different data types under one name or one roof. Okay, so it is like collecting or squeezing multiple variables of different data types and naming them as a single data type. And let me tell you, structure is also a user defined data type, so you can define it as you want, right, according to your needs and requirement. So it is a user defined data type which can store two or more different data type variables as one. Okay, so there's another type of structure which we'll be using in linked list, that is a self-referential structure. Now what is a self-referential structure? Let me tell you, a normal structure but with a small twist of a pointer. Why do we need a pointer in a structure? As the name itself suggests, this pointer will be used in order to refer back to this structure data type itself. Okay, so we'll be using this pointer in order to refer back to this data structure, and you'll get to know why is this very important when you're building linked list. Okay, now as I said, malloc function, there's another function which comes under the library of standard library.h, and this malloc function is one of my favorite functions, and it plays a very crucial role in memory allocation, especially dynamic memory allocation. Using malloc function, you can allot a memory space in your computer and it returns back a pointer to this particular memory space. I hope you're getting this right. If you use a malloc function, it creates or allocates some memory space in your computer dynamically, and then it returns back the pointer to this particular newly allocated memory back. Okay, so I hope I'm getting things clear over here. And the syntax of defining writing a malloc function is, here you go. You have to first define the data type of the pointer. Okay, as you're getting a pointer return, you have to define the data type of the pointer, and then you have to define the data type of the malloc pointer, that is malloc function, and you'll be using size of function in order to set your size, or set the size of memory space. And this is how you'll be setting the size. For example, if you want to set a size of a particular structure, you can give it as I've defined it over here. So don't worry, this might seem really complicated to you now, but I'll be explaining all this to you easily in the upcoming part of this video. Now, let us get into the interesting part of linked list tutorial of this particular video. Let us start coding. Okay, so first is, let us go step by steps, right? Steps in creating a linked list. First is include the libraries. The very first library which we've got to include is standard input output, right? Now with this, we also need standard library.h, std.stdlib.h, as it contains all the malloc, calloc, free and other memory allocation functions. Okay. Now, I'll also be doing some string operations, hence I've got to include the string library. Okay, I'm done with these three libraries. Now, let us start with the, sorry, what is the next part? Creating a self-referential structure. Now let us create a self-referentiating structure of name node itself. Type definition structure node. Okay. Now what I'm doing here is I'm defining a data type structure and I've named it node. So the identifier here is node, and the reason I'm using type def is I don't want to use the a struct node again and again, hence I've used type def in order to use just the identifier. Now I've got to store three main data into this. One is character, my name of size 20, then character USN of size probably 8. Since we are building a self-referentiating structure, we have to define a pointer of data type struct node. Okay, we have to define a pointer of data type struct node itself. So struct node. Okay, next. So the pointer, I'll name it as next itself. So we are done with the self-referentiating structure. Okay, now what I'll do is I'll get into the main function. Now in main function, we have to define one declare one pointer which will be acting as a head, right? We have to have a starting point, right? So this starting point will be known as head. So this head is again of type struct node head, and the initial value here will be null. So the pointer head will have initial value null and it is of the type struct node. Okay, once we're done with this, now as you can see, I'm trying to fetch the name USN of a particular student. So what I need here is character name 20, character USN being probably 8, and then I've got to have another variable that is choice of type integer. Okay, done. Now what I'll be doing next is I'll be using printf statement start, using while loop. I'll be running this block of code infinitely until I exit out of it explicitly. Okay, until I want to exit out of it manually, this code will be running for infinite amount of times. So what we'll be doing here is printf enter your choice. So what are our choices? First one is printf 1 means insertion of new node. Okay, printf 2 display the nodes, and printf if I choose 3 then we'll be exiting out. Okay, done. So I've given the user option. Now I've got to take the input from the user, right? So what I'll be doing here is I'll be using scanf statement to take the choice of the user. Done. Okay, now what I'll be using is I'll be using switch statement in order to run the code, control the code according to user's choice. So case one is, as you can see, is insertion of new node, right? What I'll be doing here is printf, sorry, now as you can see, I'm asking the user to enter the name as well as the USN. Once I get the name as well as the USN, now I have to call a function which will create a node and enter these values. Okay, so let us create a function, create a node. Okay, now for this particular function we have to pass the address of what, this particular pointer. Okay, so that is head, name and USN. Okay, now let us define this particular function. Let us define it above main function. Okay, this is of return type void, so it won't be returning anything, so we'll be keeping it as void itself. As you can see, uh, yeah, so as you can see, now we have to declare this particular parameters. So head is of structure data type structure node, right? Structure node, and it is a pointer to pointer head. Now again, this is a character name and this is character USN. So I've declared the parameters through which I'll be taking in the arguments. Now let us start with the main part of this particular program. Remember, this is the most important block of linked list. Okay, so you have to make sure that you get a proper understanding of this particular block. Now we have to create a new node, right? In order to create a new node we need a pointer. Yes, so this pointer is again of what, it is of again data type struct node. So struct node, new node. Okay, I'm naming this pointer as new node. Now here I'll be declaring the data return type of the pointer, that is again going to be struct node, memory allocation, size of. Now make sure that at the pointer, the memory which will be allocated will be exactly of this particular size, the size of this structure, so that whatever data I'll be storing won't overflow the particular memory space. So size of struct node again. So I'll explain this statement again to you. I am creating a pointer of type struct node. Okay, so this pointer will store the address of the memory location which has been allocated, which is supposed to be allocated. Now as you can see, this is the syntax of malloc function, the return type of pointer, malloc, size of, and the size which I'm giving is the structure node. Done. Okay, okay, so we are done with this particular function. Now our node has been created. Now what I have to do is, using this node I have to input the values of name as well as the USN. What I'll do is string copy. Okay, now new node, using arrow operator, name, I'll be copying the value name. I'll be explaining this code to you, just a minute. Okay, now what is happening here is I'm copying the argument which I'm receiving as name, okay, into the name variable of the newly created node. As you can see, I'm copying the a parameter which I've received, the name, into the newly created nodes variable name, as well as I'm doing it same with the USN. Once I'm done with this, I'm done with name, right? I've copied name, I've copied USN. What is the next thing I've got to copy? I've got to copy the the pointer to the next node, right? So I've got to set that next node. What I'll be doing here is I'll be giving the pointer head over here. Okay. Once I'm done with this, I have to again I have to change the value of head is equals to new node. Now this might seem a little bit complicated to you right now, but once we start to visualize this, once I start to visualize this using the PPT which I've created, you'll get a proper understanding of it. Okay, so as you can see, I've made a small changes over here. I'll explain this block of code again to you. In the first statement, what I'm doing is I'm creating a pointer of type struct node. Okay, so this pointer will store the pointer which has been returned from the malloc function. So this pointer which is being returned from the malloc function is of type again struct node, and it is allocating the data or size on a memory block of computer which is enough to accommodate this particular data types or variables. Okay, now what I'm doing in second and third statement is I'm copying the the whatever the arguments I'm getting, that is the name and USN, into the name and USN variable of the newly created node. Okay, now in the fourth statement what I'm doing is I'm placing the head operator, that is I'm pointing the next node to the head operator. Okay, in the next part what I'm doing is I'm changing the head node, that is the head variable, to the newly created node. So what the program will be doing is it will be referring to the head variable, head pointer, and through that pointer it will start to traverse the node. So the newly created node address will be stored in the head pointer. Okay, so I hope I'm clear with this. Now we're done with create node. Now what is the next option? Next is case 2. Now with case 2, I have to display this particular list. So let us create a display function. Now with display function, I have to pass the head, right? Now why do we need to pass head or head pointer in display function? Remember, the compiler traverse from the head to next node, and the until very last node. This traversing starts from the head itself. Okay, so this is how we'll be doing using the head node. Yeah, as you can see, I'll let us declare the display function. Now the display function will again be receiving a arguments on parameters which is of type node struct node. Now here comes a twist. While the head is not equal to null, keep on printing. Printf name is percentages /t, USN is percentages \n. So what I'll be doing here is I'll be using the head operator. I'll be using the head pointer itself, head pointer, in order to access name, and again head pointer to access the USN of the particular node. Once I'm done with this, once I'm done with this first node, I have to go to the second node. So that happens with head is equals to head of next. So what we'll be doing is in the node itself, we'll be taking the pointer which is in the next variable and we'll be placing that in head, so that the next traverse starts from that particular node. So I'll be explaining this to you visually, so you don't have to worry about it. So let us check if our program is working right now. I'll come up with the case 3, that is exit. So this was our code. Let me try to debug this. Okay, we've got one problem over here, that is the display. Okay, so our code is running fine without any errors. So as you can see, first we are being asked for our choice. I'll enter one, insert the data into new node, enter name. Let me enter Amir. then USN 21 IS 123. Okay, then I'll again enter a new node, Salam, 21 IS 124. Okay, then again I'll insert another node, Danish. Yeah, Danish is my another name. So USN is 21 IS 125. Okay, so what I'll do here is I'll again display whatever the nodes which I've entered, that is option 2. As you can see, the nodes have been displayed. The name is Danish. See, this is how easy it is to code the linked list program. Now, I know this was a little bit complicated for you guys. I'll explain this to you visually. Let us start with this particular block. Initially, the function which we had, right, the create node function. With this create node function, we passed the pointer which had address of head. Then we passed strings Amir as well as the USN. Now with this, in first initial part itself, the head had null. That means it was completely empty. In second part, a new node was created, and this new node, the address of this particular new node was stored in head, and the data was stored in this particular new node. Once I clicked on another time, that is insertion of a node again, as you can see, the next node was inserted over here with its the pointer, the head pointer pointing towards the address of second node, and this next node next pointer pointing towards the address of the next node. So this was the final list which we have created it. So this is how easy it is to create linked list using C. So I hope I have made all the points clear, and I hope you guys have got a very basic introduction or understanding on linked list of data structure algorithm. If yes, then consider hitting the like button, and also subscribe to my channel and share this video with your friends also. So all the notes which I've used in order to explain this topic, I'll drop a link to those notes down in the description box, so you can go and download all these notes from there itself. So that's all for this particular video. It was a little bit a lengthy video, but I think it was worth it. So that's all for this particular video. See you in another one. Till then, bye bye.